like we're on, etc. And got the stories lined up. And the questions are there. Yep. Right. All right. Got them all. Everything's good. Are you ready?
As ready as I'll ever be.
All right. Let's do the TikTok. 3, 2, 1. Hi there. Thanks for joining us. Hope you can. No, that's wrong. Start again. bit out of kilter.
Out of practice. It's been a while.
Yeah. Okay. 3, 2, 1. Hi there, Andrew Dunkley here from Space Nuts, the Astronomy podcast, and we will be back again with a new episode real soon. And joining us will be Professor Fred Watson, astronomer at large. Hello, Fred.
Good morning, Andrew. Oh, sorry. Good day, Andrew, I should say.
Well, it's morning at the moment, but it might not be by the time someone TikToks us.
Quite so.
What's coming up on this episode?
Yeah, some new research from Mars, your favourite planet, which suggests that the chemical formaldehyde had a role in perhaps spreading what we might call prebiotic chemicals, organic chemicals, the sort of building blocks of life on the planet Mars. And which is the smallest exoplanet? Which do we know? Which is the smallest one? And we'll work on that.
I could guess, but that would give it away, possibly. All right. Yeah. And we will also be dealing with some audience questions about planets and photography and orbits, and could a moon have a moon? And HDF 110067. That's a star system that Scott wants to know about. We'll deal with all of that on the next episode of Space Nuts. Fred, are you ready for a dad joke? Is anyone ever ready for a dad joke?
No, I don't think so. I think that's the rule of dad jokes. No one. It's like the Spanish Inquisition. No one expects a dad joke.
No. I got a feeling you'll get the answer to this one. Why did all the pecans go to space?
Because they were astronauts.
Oh, close. Well, I'll give that to you, but they were space nuts.
Space nuts. That's even better. That's a good plug for the show.
Not bad.
I suppose mine's got a similar flavour. What's the most common plant in space?
Ooh. No, don't know.
It's the Venus flytrap.
Oh. Should have figured that one out.
Yeah, it's an oldie but a goodie.
All right. Thanks, Fred. We'll see you very soon. Don't forget to join us on Space Nuts, coming to your favourite podcasting platform soon. Okay.
That's good. Got rid of that.
Yeah. Oh, we're going to try Instagram Live today. Hello. Hopefully that'll work. Oh, okay. It's just a test. All right. They probably can't see us. Anyway. Excuse me. All right. I'm ready to roll. If you are, we'll get this show on the road.
Yeah, let's do that. That's probably the next thing to do. So
probably. Okay, here we go. In 3, 2, 1. Hi there. Thanks for joining us. This is Space Nuts. My name is Andrew Dunkley, your host. It's really good to have your company. On this episode, we're going to be looking into a new report that suggests that things happened on Mars a long time ago that have added more evidence to the possibility that it could have harbored life, or at least started to make progress towards having some form of life. And it involves a chemical, I suppose, that you know and probably don't love. We're also going to be looking at the smallest exoplanet ever found. Will it retain that title for long? The word is possibly not. We'll explain why very soon on this episode of Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us to talk about all of that and much, much more is Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Yes, still at large.
Yeah.
Everybody thinks it's a joke title, but it's actually the name of my job.
Yeah, it is. Yeah. Well, it used to be astronomer in charge, but there was no one to be in charge of after a while.
Well,
so had to redesignate you.
Yeah, something like that.
Yeah, it happens. It happens. So how you been? I mean, to the unwary, we've been together every week for the last several weeks, but I've actually just come back from Egypt. So
you have, and I'm very anxious to hear how it went.
Well, I'll start with the bad news. I think I caught COVID.
Yeah.
So I spent most of that trip actually under the weather. But on top of that, what a fascinating place. What incredible history. And I don't know what to tell you was the best thing I saw. The pyramids and the Sphinx go without saying. The Valley of the Kings was extraordinary, getting down into the tombs in the Valley of the Kings and seeing the elaborate artwork and the hieroglyphics and and some of the things that they did to try and trick the grave robbers, like little sand traps and wells and false sarcophagus and false walls and just so many amazing things that they did to ward off the looters. The Civilization Museum was an eye-opener for me because that's where the mummies are. There's only actually one mummy that's remained in the Valley of the Kings. Do you know which one it was?
I don't know.
It's
remember.
Tutankhamun. That's the way they pronounce it. Yeah. He's still there because his body is too delicate to move around. But the rest of them are in a museum in Cairo called the Civilization Museum. Highly recommend that because you can actually go down under the main exhibition floor and walk from one chamber to another and get up close and personal with the pharaohs. And they're all there. They're all there. All the Ramesseses. There's a whole bunch of them, including the famous Ramesses II and just so many. And yeah, real eye opener. Luxor, I really liked Luxor and the temples. I'm pretty well templed out. I don't know how many we went to, but gee, we saw a lot. But they're all part of the story, and that's what the tour was about, to try and piece together this amazing history. We even went to a granite quarry where they mined pink granite to create those famous obelisks. And
is that the one where there's an obelisk that's still half finished?
Yeah, and it's split. It broke, so it's still lying down in the ground, not completely cut out of the ground. So they'd given up that project. But can I show you something? Hang on a second. Wherever I go, if there's a rock worth collecting, I get one. So that is a piece of pink granite from the ancient granite quarry in Luxor.
You've probably just broken the law by showing us that. And you're going to get space nuts hold of the coal.
It's allegedly a piece of pink granite.
Allegedly, yeah.
But yeah, what an amazing place. And we did a river cruise on the Nile and spent 3 nights on the boat. And then we went to a Red Sea resort and hung out there. Someone said to me, I'll be really keen to see how you feel when you come back as to whether or not you really believe the Egyptians could have built the pyramids. That's not a nice question. I think Cairo surprised me. I didn't expect it to be quite as third world as it was. And yet, just up the road, they're building New Cairo, which is modern and dynamic, and there is an astronomical connection there, Fred, that you were telling me about.
That's right, yes. So, of course, when we were there in 2018, part of our tour, which Marnie put in specially for me was to visit a telescope that's actually quite close to my house. It's a big telescope at a place called Kotamia, if I remember rightly. It's Helwan is the nearest place. It's 74-inch telescope, a large one, a classic of its time. But unfortunately, New Cairo is going to essentially brighten up its skies to the extent, because of light pollution, to the extent that it won't be viable anymore, which is a great shame because telescopes last a long time. This one was built in the 50s and it's still going strong.
Yeah. Well, having seen what they've done, I was told 2 years ago it was nothing. It was just desert. And now you've got this mega city, 13-lane highways. It's just extraordinary what they've done. So, yes, I do believe that the Egyptians built the pyramids.
There you go.
Yeah, not aliens. Definitely not aliens.
It wasn't aliens, no.
I know I've spent a bit too much time on this, but I'll just tell you a little bit about issues with language and translation. Had an incident where we were staying at a hotel, and I asked for the Wi-Fi password, so they gave me a menu. I twice asked for white wine and got red wine. I once asked for coffee and got tea. And we asked one of our guides what the length of the Gaza road was because, obviously we're interested in where Gaza was. And he said, that's the Gaza road and it's 5,000 kilometres long. And I went,
oh, okay.
Yeah, maybe not, seeing Gaza was 350 kilometres away. Yes. And the other funny thing, we asked him the population of Cairo. And I think he knew, but he couldn't put it into the right words. So apparently there are 30,000 people living in Cairo.
Okay. Might be.
But, yeah,
that's a lot of that's language issues. Isn't
it was. It was definitely. But an amazing trip, and we felt safe.
Good.
They're very careful over there, and never really felt there were any issues or dangers. And they take security pretty seriously too. So, it was a good trip. Pity I got sick early and had to live with that all the way through. But and now jet lag. So I'm sitting here with both at the moment. So apologies if I disappear and
it's okay.
It's just mucus. Nothing to be scared of. Now, Fred, we've got a lot to do and I've burnt a lot of time. So let's get into our first topic. And this has everything to do with Mars and its past and the possibility that it could have, at some stage in its history, harboured life. And a new paper has been published which adds a little bit more weight to that theory.
Yes, that's right. And it comes from Japan, Japanese researchers who've done some modelling of what Mars's ancient atmosphere might have been like, and what they've done, and by that I mean the period. I think it's called the Noachian period, if I remember, something like that. Anyway,
as against what is the no ocean period now.
Yes, that's right. And when there was liquid water on the surface because the pressure was higher than it is now, the temperature was warmer than it is now, and what we're talking about is a period. In fact, it's that early period from about 3.8 to 3.6 billion years ago. And what these scientists have done is looked at the kind of gases that are coming out of volcanoes and what they contain, and basically you've got things like hydrogen, carbon monoxide, carbon dioxide and water, and they've sort of envisaged that these chemicals would have been in Mars's early atmosphere, and what they've modeled is how they would change. And it turns out that because of solar radiation, the photons that come from the sun, you get chemical reactions. For example, carbon dioxide turns into carbon monoxide, water turns into hydrogen and oxygen. You put all these things together and you get formaldehyde, which is a very well-known chemical that we think of as a preservative for specimens in jars.
did the Egyptians use formaldehyde?
I wouldn't be surprised. I think so.
Yeah.
Yes, probably in mummification. Yes,
Yeah.
that's right. When you take that modelling, yes, you get formaldehyde. You can probably then dissolve that in the the water oceans. But either way, the existence of formaldehyde basically means that you've got a sort of, and let's do the Egyptian thing again, a Rosetta Stone for some of the other molecules that could form from formaldehyde reacting with other different chemicals to form carbon-rich molecules. The sorts of things that we think of associated with life, like amino acids and things of that sort. So this research, again, it's sort of, I suppose, leaning towards the optimistic side regarding life on Mars. One of the researchers, there's a lovely quote here, and I'm reading from SciTech Daily in this particular story. The researcher says, "Our research provides crucial insights into the chemical processes that may have occurred on ancient Mars, offering valuable clues to the possibility of past life on the planet." This is Shungo Koyama, and that's the lead author of the study. And so it's basically, it's broadening the research, broadening the level of possibilities that we have for the formation of what we would call biomolecules, the molecules that basically go into living organisms. Now we're finding those all over the place. We find them on comets and even asteroids. But to find a reaction that can actually generate these chemicals on the surface of ancient Mars is, I think, a step forward. It's a very interesting piece of research, and once again provides some optimism for people who are looking for, perhaps in the end, when we get the samples back from Perseverance, we might be looking for evidence of past living organisms, fossilized perhaps in the dust and soil of Mars.
Yes, that's the $64,000 question, isn't it? And this just seems to add a little bit more fuel to the fire.
Yes, that's right. It does indeed, which is, it's a step. It's an interesting step and a nice piece of research. I'm no chemist, but I admire people who can work out what these reactions are and tell you what comes out at the end.
Yeah, I suppose we should add a caveat and say they're basing this on a few assumptions,
Yes,
which
that's
sometimes
correct.
you have to do. So it's
Yes.
not an absolute,
No.
but the assumptions are fairly sound.
Yes.
And that is the existing conditions on Mars at the time. But yeah, we know in its history it probably had liquid oceans, it was warmer, and now this could add another little piece to the life puzzle. Will be astounding, and hopefully in the not too distant future, we will have answers.
Yeah,
What it's all about.
the answers, or the nearest thing we'll get to answers, will be when these samples come back from Perseverance, which I think it's laid a cache of something like, is it 17 samples left around on the surface of Mars? I know that the planning for the recovery mission for these is in trouble in terms of finances and things. This is meant to be a joint ESA-NASA mission. I think it was originally scheduled for 2028. I think there's issues with that. I haven't followed up on them, but it looks as though people are raising questions about it. So we'll have to see how that goes. It is a very important mission, of course, to bring back for the first time samples of Martian soil.
Yeah, I still kind of shake my head about the fact that they created such a fabulous mission to collect the samples, but they put the collection idea on the back burner, and it's still on the back burner. So
I hope it won't stay there for very long.
Yeah, well, those things have been up there for billions of years. They're not going to go away.
No, that's right.
think, we'll get around to it eventually. That's what people do.
That's what I do.
Yeah. No, yeah, I'll get to those weeds in the garden.
Yeah, there's a few things like that.
Eventually. All right. If you would like to read up on that story, as Fred suggested, the scitechdaily.com website is a great place to start. This is Space Nuts. Andrew Dunkley here with Professor Fred Watson.
It's one small step for man, one giant leap for mankind.
You're listening to Space Nuts, the podcast about astronomy and space science with Andrew Dunkley and Professor Fred Watson.
You are indeed with us, and we're grateful for that. So thank you. Now it's time to look at things beyond our solar system, and a lot of the time they are exoplanets. And we have now discovered the smallest exoplanet ever found, Fred. This thing's, I suppose it's really tiny, but it's opened up that debate on, okay, is it a planet or is it something else?
Yeah, that's right. That's why it's in the news. It's just the question about whether this object, which actually has been known for about 10 years, I think, whether it is a planet. So what are we talking about? We're talking about an object called Kepler 37b, and it's an object that was discovered by the Kepler mission. And we should just recap on that. It's now Kepler is now not operating anymore, but that mission, which was incredibly successful, was to measure the brightness of stars very, very accurately and measure them over time. I think they did it 100,000 stars at once, if I remember rightly, and to look at the way the light from those stars varies and to detect when objects pass in front of those stars. So that means you have to have a planetary system around the star that's actually aligned with the direction back to Earth, and there's quite good statistics on how many you might expect to find like that. But indeed, it was so many that many thousands, I think it was 3,000 or 4,000 planets were detected by Kepler as they passed in front of their parent star, caused a dip. Next time round, they passed in front of their parent star, caused another dip. And I think if you get the third one, that's when it is classified as a planet rather than being a suspected planet. So Kepler was really successful at this. And the reason why it sort of revolutionized the planet finding process was before Kepler, the main way of finding planets was the Doppler wobble method, where you're looking for wobbles in the motion of a star backwards and forwards, towards and away from you, that have been caused by a planet pulling the star slightly out of place. Now that's a great way of finding big planets, but for little ones it's pretty grim, because the pull of a little planet is not very great on its parent star. Whereas the Kepler method, what's called the transit method, because the planet transits across the disk of the star, that is very sensitive to actually quite small planets. And just to spill the beans on how big we think it is, Kepler 37b is actually about the same size as the moon, which is a quarter of the Earth's diameter. Now that's the record breaker at the moment. But the question, I guess, that was raised was, is it really a planet? Is it an asteroid or something that's not spherical?
And that is something that we Earthlings have defined through the Astronomical Union, and it has to meet certain criteria to be defined a planet, which Pluto couldn't do anymore, and that's why it was redesignated in 2006.
That's correct. On, if I remember rightly, the 23rd of August. That was the date, I think, of the vote, which is still controversial, honestly. But my view, as you well know, is that it was the right decision. So the criteria, and this is the nub of this story, it's got to orbit a star or the sun, in the case of the solar system. It has to be big enough that this process called differentiation has pulled it into a spherical shape. In other words, its own gravity has overcome the resistance of the rock, which is probably molten back in the day when it was being formed. Its own gravity has overcome that resistance and pulled it into a sphere. But the third criterion, and this is the one that Pluto fails on, is that it's got to be the dominant object in its neighborhood. It's got to have gravitationally cleared other objects out of the way.
Yeah.
And if it hasn't done, then it is a dwarf planet, which is why that new categorization was introduced. Something that's spherical but hasn't become the dominant object. It's a dwarf planet, and indeed Pluto isn't the dominant object. There are other things that are equal in size to Pluto, and probably things that are bigger that we haven't found yet out there in the depths of the solar system. So that's the question in relation to Kepler 37b. Has it cleared its own area of the region around its parent star, which is called Kepler 37? And the answer is it's really hard to know that, because the stuff that will be around it will be very small. But I think basically the upshot of the research that is being described here, it's a scientist, and I can't remember. I think it's Thomas Barclay is the name, but I can't remember. Yes, Goddard Space Flight Center.
Yes,
Thomas Barclay, Goddard Space Flight Center. And in fact, Thomas was the first author of the paper 11 years ago that actually identified that planet as being a planet, Kepler 37b. I think what has happened now is to look in more detail at the star itself, because we can learn things about stars from a topic that we don't often talk about, Andrew, even though it's actually well pursued here in Australia. There's a very strong group at Sydney University that look at this topic. It's called asteroseismology, and it's about vibrations in stars. You can even apply this to the sun. The sun's got I think they're about every 5 minutes the sun wobbles slightly. It's a natural oscillation, and you can see those in the brightness of the star. And I think they've made, just by looking at these oscillations, what they've done is got a better estimate of the diameter or the mass of Kepler 37b, and essentially it is what we said. It's about the size of the moon, and that's really the remaining place where we are at the moment. It's definitely that size. That the likelihood is it's spherical, because an object in the size of the moon, what is it, 2,500 kilometers or thereabouts? It's actually a bit more than that. It's getting on for 3. Yes, it's over 3,000. Sorry, 3,200 or something like that. That size, it will have become a sphere. It will have become spherical. The gravity is enough to pull it into that spherical shape. So the only really remaining question as to whether 37b qualifies as a planet is whether it's cleared the region around it. And the suspicion is, because it's so close to its parent star,
it's
it only
very
takes
close.
13 days to go around once. The likelihood is that stuff is long gone. And so we, I think, are still holding Kepler 37b up on a pedestal as the smallest planet known outside the solar system. And in fact, it is the smallest planet because it's actually smaller than Mercury. But we are looking forward to the launch in 3 years' time of the Nancy Grace Roman Space Telescope, which is a kind of Hubble-like telescope that's going to do all sorts of interesting things because it's got a wide field of view. And that will be detecting exoplanets by a different method, not the transit method, but one that has actually found favor from astronomers on Earth, not just in space. It's called gravitational microlensing. And what happens is if a planet passes in front of the light of a star, its gravity changes the brightness of that star, because this lensing process basically focuses the light. It's gravitational lensing is the phenomenon where space is distorted by a galaxy or a planet, or something like the Earth. Space is distorted by that, and what you get is a lens in space, effectively a lens. and that can magnify the light of a distant star. Gravitational microlensing has been very successful in finding new exoplanets. Not as successful as the transit method, but if you've got a big telescope looking out for these things, you might discover thousands of exoplanets by this technique. And the Nancy Grace Roman Space Telescope, if I remember rightly, it's about the same size as Hubble, is on the trail of this. So in a few years' time, we might find another huge trawl of gravitationally microlensed planets, and maybe we will find one smaller than Kepler 37b.
In fact, I think they are anticipating that's a probability. Because this method, they believe, is going to catch quite a big cluster of planets in this. Where are they going to look exactly? Anywhere they can.
Yeah, it's a really sensitive technique for small planets. I might just add that colleagues in New Zealand are actually particularly involved with this technique. There are various projects, all with quite entertaining names. I'm trying to remember one of them. I've forgotten what it is. Microfun. That's it. Microfun is one of them, which I like. Ogle is another. So colleagues in this part of the world are very active in that process, including some amateur astronomers as well.
Okay. If you would like to read about the discovery of, not discovery of, but the confirmation that 37b, Kepler 37b, is the smallest exoplanet thus found, you can do that at space.com. Fred, we are done for another day, and I just remind people that you can go to our website and have a bit of a peruse and get in touch with us there. And don't forget, if you're a YouTube follower and you watch us on YouTube, don't forget to hit that subscribe button down below.
Where is it again, Andrew? Where's that subscribe button?
Down below.
That's great.
Down there somewhere.
That's the one.
Yeah. Fred, thanks so much. We're done for another day.
Sounds good. And I look forward to the next time, Andrew.
Indeed. Professor Fred Watson, astronomer at large, part of the team here at Space Nuts, the podcast. And thanks to Hugh in the studio, who's been basically sitting on his hands for the last few weeks because he's had nothing to do. That's different. How? I'm not sure. Anyway, from me, Andrew Dunkley, thanks for your company. Catch you on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast.
Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.
Okay, that one's done. Yeah.
You're not feeling so good, are you? I can tell.
No.
Yeah, I've got a missus who's a bit like that at the moment as well.
It's been a right royal pain, I'll give you that. Okay, now I just got to find the second question, which is that one. All right. Okay, let's get part 2 up and running. Here we go. In 3, 2, 1. Hi there. Thanks for joining us on Space Nuts Q&A. My name is Andrew Dunkley, your host. It's great to have your company. And we thank our audience for sending in questions. We got some new ones the other day, so we're going to try and knock off a few of those in this episode. Viano has got in touch with us this week. He's asking questions about planets and photographing planets and missions to distant planets that we might be able to take a look at. But will there be problems if we want to send back images? We've got a question from Brady. Could a moon have a moon? That's a good question. Let's look into that. And Scott is asking about the star system HDF 110067. I'm sure you know it well. We'll find out all about it this week on Space Nuts.
15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
And joining us to tackle all of those questions with most insightful answers, Professor Fred Watson, astronomer at large. Hello, Fred.
Hello, Andrew. Hopefully this will be Q&A rather than Q and not A.
Yeah.
Which is always the risk.
Yeah, it is a bit, but, even when we get questions we can't answer, which we've actually received while we've been talking today, we will chase them up if we can. So never be discouraged. We'd love to get your questions, and we'll tell you how to do that at the end. Let's go to our first question, Fred. And this one, as I said, comes from Viano.
Hi guys, Adriano from Florence in Italy. So I have 2 questions for you. The first one is related to the Breakthrough project. You told us that they want to reach Proxima Centauri with a sort of solar sail at around 1/3 of the speed of light, which I think it means more or less 100 kilometers per second. I worked with industrial cameras and I know how difficult it is to find the right exposure time, configuration, the optical lenses, focus, and so on. And I was thinking that maybe it will not be possible to take a clear picture of a planet if you are moving so fast in front of it. What do you think about that? The second question is related to the planet's orbit. So can you please explain me what is that defines the distance between the planets and the sun? So for sure there must be a sort of gravity equilibrium, but I cannot understand why they are not in order considering their mass or their volume. So there must be something else. And so, guys, I started listening to you because I wanted to learn some English. I'm pretty sure my English is not so good or improved, but I started looking at the sky. I love the stars now. I think it is great. So thank you, guys. Bye-bye.
Thanks, Viano. I'm a little bit disturbed that you think we're going to be helpful with your English, but no, I'm really pleased that you sent us a question. Your English is actually very good.
It is.
And
very good indeed.
Yeah, we understood perfectly what you were asking us. But yeah, thanks for sending in a question. It's greatly appreciated. And having been in Florence fairly recently, what an amazing place. You live in a beautiful part of the world. I happened to be there at All Saints weekend, which is a 4-day public holiday. And there were thousands and thousands and thousands of people there. It was almost impossible to move through the city square and see all the sights. Just everyone flocked to Florence that weekend. Big religious holiday, but what an amazing place. Yes, and beautiful part of Italy too. It's just extraordinary around there. Now, he mentioned the Breakthrough project. This is the plan to send micro spacecraft on a flyby of Alpha Centauri, the planets of Alpha Centauri B, is it? And they won't be able to stop. I remember us talking about that. So let's just sort of review what Breakthrough is about and then try and answer Viano's questions as to whether or not we'd be able to send back a photo or two of the planets involved.
It is actually a great question. And I think there's quite a lot of subtlety to it. So it's a Breakthrough Starshot. And that project was initiated by Yuri Milner, the Russian billionaire who set up the Breakthrough Foundation in order to study the possibilities of using light sails, laser-driven light sails, to accelerate a spacecraft which might only weigh less than a kilogram. You know, it's tiny stuff we're talking about, to a speed which would allow you to reach Proxima Centauri, the nearest of the Alpha Centauri system, a red dwarf star, within a reasonable number of years. And so, if you accelerate it to a third of the speed of light, 100,000 kilometers per second, as Viano says, then you're probably going to take, allowing for acceleration and deceleration, you're probably going to take less than 20 years to get your 4 light years away. and then you're faced with the issue, and it probably wouldn't be just one spacecraft. I think it will be a little flotilla of sail-driven spacecraft.
Yeah.
Which would fly along the laser line, accelerated. I'm sorry. There's the people are complaining about our rooster, Andrew. They think he's a chook. They think he's a cockerel. He's not. He's a dog with a stupid voice.
And he does that when someone turns up.
He does, or even when somebody turns up, he just does it because he
just does it occasionally. Yeah.
I've counselled him.
It's the nature of the breed.
Yes.
It's the nature of little terriers, or little terrors, whichever way you want to look at it.
That's right. Anyway, you whiz through the Proxima Centauri system, and it does have planets at 100,000 kilometers per second. You've got cameras that are supposed to be able to photograph planets. You want to photograph them in enough detail that you can actually see what's going on their surface.
Yeah.
That is an incredibly difficult problem. The nearest thing I can draw a parallel to, which was very successful, was New Horizons flyby of the Pluto system back in 2015. Is that right? 14th of July, 2015. I think that was it.
Let me check.
Brains. Yeah, you check that. And actually, I might have the 14 might be something else, because my recollection is that the flyby velocity.
The 14 was the 14th of July, 2015.
There you go. That's got it right.
Yeah.
Check the other figure for me, though, Andrew, because I think, if I remember rightly, the flyby velocity was 14 kilometers per second.
It's I haven't got that, but I will look it up.
Okay, just to make sure. So, and that was an amazing feat of engineering.
23 kilometers per second.
Okay, 23. So I'm mixing up the 14 with the date. Yeah, 23 kilometers per second. Are you sure that was the flyby velocity? That sounds more like the maximum velocity.
Well,
me.
hang on. I'll keep looking. Hang on a second.
Yeah, I think I think it was the fastest spacecraft ever launched, because at one point in its trajectory, probably after
here it is. New Horizons flew within 12,500 kilometers of Pluto at a relative velocity of 11 kilometers per second.
Okay, that sounds more like it. Yes. 11 kilometers per second. So it's a very small percentage of 100,000 kilometers per second, which is what the flyby speed will be for any breakthrough Starshot initiatives. But it was highly successful. What they had to do, because you can't control this in real time, Andrew, because you've got, I can't remember what the time delay was, but it was minutes out to get the signal out there. And this thing flashes by. So they had a pre-arranged sequence of shots, the camera angles to get not just Pluto as they flew by, but Pluto's moons, all of them, including the biggest one, Charon. They did fantastic planning and built into the engineering of this, so that when the spacecraft got within X thousand kilometers of Pluto, this sequence started and it was executed perfectly. It was just a choreographed set of imagery. And of course, I guess we're all familiar with the dramatic pictures that were returned.
Amazing pictures. 6 hours, the time delay.
6 hours, there you go. Yeah. So thank you. I'm glad you're there. It's a long time ago. What's that? It's 9 years ago since all this was happening, and I gave talks on it. I talked about Pluto about 100 times, I think. So I knew the numbers, but it's receding into the past. Anyway, to the issue that Viana raises, we have a different set of circumstances here. We've got these tiny little machines which have cameras on board, pointing hopefully in the right direction. you've got a 4.5-year time lag back to Earth, so there's no chance whatsoever of pointing the thing. It has to all be done robotically, so you're going to have sensors on board that will look for the brightest object in the field of view and basically point your camera towards it. But at 100,000 kilometers per second, there are also what we call relativistic effects. The geometry of space changes. So you're not just taking, saying, well, we know where these things are, we can point the camera at them. You've got to take into account the fact that space is distorted by the relative velocity, 100,000 kilometers per second, third of the speed of light.
Hey, space nuts.
Sorry,
which will,
that was me.
which will change the directions of the things that you're looking in. It basically squashes the stars forward in your field of view, that relativistic effect. So all those phenomena, and I think, if Viano's raising doubts about whether this is feasible, I think he's right on the money, because I think it is so difficult to do.
Yeah.
We don't even know whether the technology would work to get us there in that length of time, but it's a very interesting problem, and it's one that needs to have interesting answers.
Yes, indeed. I mean, he brought into play other effects like the distance of the planet from the stars, exposure times, just so many other factors that need to be. Yeah. And I'm sure the scientists involved would take that into account, but there's certain things they won't be able to control. And when you're talking robotics, once they're on their way, that's it. You're not really going to be able to do much once they get too far away to take those photographs and transmit them back. You just going to sit and wait and hope and pray that it all works.
And then 4.5 years later, you get your pictures back.
Yeah, and it's just a fuzzy blob. Yeah.
Yeah. The other bit of Viano's question was about the orbits of planets, and it's why are planets in a particular orbit? There's the orbit is basically dictated very much by the distance. The two go completely together. In fact, the mass of the object itself is of less importance. For example, on if you're in Earth orbit, if you're at 400 kilometers, you've got to have a certain velocity to stay in orbit, whether you're a CubeSat or whether you are the International Space Station, much more massive than a CubeSat. So it's all about the orbital velocity and the distance from the sun. That's what dictates basically where planets stay. They've obviously formed there at those distances. We think the gas giants are gas giants because they're beyond the frost line, so that they grew big as they accumulated ice. And that made them, gave them the possibility of accumulating still more material, the gas around them. Hope that answers the question, Viano.
Viano, thanks very much, and so good to hear from you, and hope all is well in Florence. This is Space Nuts, Andrew Dunkley with Professor Fred Watson.
Space Nuts.
Now, Fred, we've got a text question that's come in from Brady. Hello from the great state of Florida, with a great view of all the launches here. Oh, you lucky duck. I was wondering if a moon could have a moon. Also, would that be called a moon? Love listening to you all every week, Brady. Thanks, Brady. Very jealous of where you are. I'd love to be able to sit and watch a few launches from Florida. What a mesmerizing place. I've been lucky enough to visit there and found it all very extraordinary. Could a moon have a moon, Fred?
Just to a footnote to that, I'll be there in about 3 weeks, Andrew.
Yes, you will.
Cape Canaveral.
Yeah. Well, by the time this episode's out, you'll probably already
last week.
Yeah.
But moon of a moon, yes. Such an object will be defined as a sub-satellite. So satellites are moons. It's satellites, the technical term that we use. Nowadays, people think of them as artificial satellites, but actually the word means the satellite of a planet, something going around a planet. A sub-satellite would be something going around a satellite. And the answer is yes, it could. Theoretically, you could have a subsatellite. You could have a moon of a moon. But the odds are that they're quite rare. And the reason for that is that we know of none in the solar system. Of all the 200 or 300 moons that we know in the solar system, I can't remember the exact number now, none of them have a subsatellite. None of them have a moon. So that is probably because theory suggests that and this would depend on what the planet was like, the planet that these things are going around. It's the tidal effects of the planet that are probably what would disturb, or what has disturbed, any possible subsatellites in the solar system. So what I'm saying is, in the solar system at least, the reason why we don't find moons of moons is because of the gravitational pull of the planets themselves. These actually would make it unstable. So you lose the moon of the moon. The moon itself might stay there, but this other moon going around it might be too unstable in its orbit just because of the tidal effects. That's the gravitational pulling effects of the planet itself. But that might not always be the case. It's the case in the solar system, but it might not always be the case. And there is at least one, basically one planet, which is Kepler 1625b, which could, in theory, have a satellite, and in theory could have a subsatellite. So that's just because of the gravitational, distribution between the parent star, which is Kepler 1625, and the planet Kepler 1625b.
Right.
That's one suggestion. But as far as we know, there aren't any in the solar system.
Okay. So for it to happen, the circumstances have to be exactly right.
Exactly. That's right. They have to be a bit special.
The answer to your question, Fred, 293 moons in our solar system.
Oh, there you go. 293. Thank you.
At last count. Yeah. Thanks, Brady. I like your name better. Moon. That works for me.
Moon's good.
Yes, it does. Now we've got a question from Scott.
Hey, this is Scott from Oregon. I recently became aware of HD 110067 system because apparently it has 6 exoplanets that are orbiting in like a perfect mathematical arrangement or something. But my real question is really about it's a part of a triple star system. And at least according to the information I found, the companion planet it's actually a companion binary star system, is 13,400 astronomical units from the primary star. And I'm just kind of curious as why, when something is that far away, is it kind of considered still like a triple star system? I just assume that they, that seems like a really far distance for them to still be kind of considered together. So I'm just kind of curious about how they kind of categorize these things. Thanks.
Thank you, Scott. That is a great question. Triple star system, but he's questioning distance and whether or not it could actually be that. That's how far is too far for a binary / triple star system?
That's look, and again, this is a great question, and it's really all about what we call gravitational binding. So that star HD 110067 is gravitationally bound to this spectroscopic binary system, which is called HD 110106. Now, that 110067 is interesting because of these 6 planets, which are in a lovely orbital resonance with each other. It's at a distance of 105 light years. But Scott's question isn't really about the planet, the star and its planets. It's about this companion binary system. What do we mean by a spectroscopic binary system? A binary system is 2 stars orbiting around their common center of gravity, usually called the barycenter. If it's spectroscopic, it means we can't see them as two separate stars. We can see them as a single star in any telescope, but we know it's two stars because the spectroscope or the spectrograph reveals by the Doppler effect that there are two sets of barcodes which are moving relative to one another as the stars orbit each other. So it's by using the spectroscope that we know that there is a pair of stars there rather than just a single one. Whereas HD 110067 itself is said to be part of this as a triple star system. So, Scott quotes, and I haven't actually verified this, but I'm sure he's right, 13,400 astronomical units of separation between them. Now that's about a quarter of a light year. A light year is about 63,300 astronomical units. Oh, what's an astronomical unit? Distance from the Earth to the Sun, 150 million kilometers. So an astronomical unit is a unit we use within the solar system. We tend to use light years beyond the solar system. But for a triple star system, that is quite a long way off, 13,400 astronomical units. As I said, it's roughly a quarter of a light year. I'm going to throw in a coincidence here, Andrew, that you probably don't know about, but the number of astronomical units in a light year is, as I said, about 63,300. Is very, very similar to the number of inches in a mile, which is about 63,300.
Oh, right. Wow.
It's a nice coincidence that we can't use anymore because we're all metric here in Australia.
Yeah, well,
anyway,
except they can use it in America.
They can, yes. But so what defines it as these two, the binary and the star itself, HD 110067? What makes it a triple star system? It's because they're gravitationally bound. The movement of the two relative to each other tell you that they are in orbit around their common center of gravity. And so once again, that's detected spectroscopically and probably actually also by the Gaia astrometry spacecraft, which can measure the positions of stars very, very accurately indeed. So I think that is why it's termed as triple system rather than just two stars that happen to be near each other. Is because they've got movements that suggest that they're gravitationally bound to each other.
They are dancing.
They're dancing. What a lovely way to put it, Andrew.
Yes. Yeah. Well, if they dance like me, one of them's going to fall over real quick.
Indeed.
So there you are, Scott. Hopefully that will appease you, at least answer your question. We got one without notice, and I know you love those, Fred.
Right.
This comes from a Facebook listener, Dean. G'day, fellas. Question for you. How does Hubble maintain a steady image of targets while in orbit?
It's stabilized. And what stabilizes it are gyroscopes, which are an absolutely vital part of the mechanism that operates Hubble. And in fact, it's why Hubble's lifetime will eventually be limited, because the gyroscopes did fail. I think they need 3. I think they can just about manage with 2, but they need 3 to work properly. Back in the day, 2000, probably 2011-ish, thereabouts. Trying to think when I think 2011 was when the last Hubble repair mission went up, and it was to repair or to replace gyroscopes. That was in the last year or so of the space shuttle, because the space shuttle was the only vehicle then available that could reach the orbit of the Hubble Space Telescope at 600 kilometers. So it's gyroscopes which have failed. They're still working pretty well as far as I know, but maybe again they will fail, and that will bring the mission to an end because you won't be able to point the telescope.
Yes, exactly. And that was 2023, I think, when it was a while further back than that. I remember us talking about those gyro failures. It wasn't that long ago. But
there might have been other ones.
Could have been
since that mission. Yeah.
I mean, Hubble's been up there at it for a very long time. Things don't last forever.
34 years.
Yeah, it's incredible, isn't it?
Yeah.
Of course, there are going to be new telescopes like James Webb in action, and the new one that ESA set up. And of course, we talked about one.
Nancy Grace Roman telescope.
Which is also going to be launched in a few years. So plenty more going up there to continue the work. But thanks for the question. Lovely to hear from you, Dean. And if you do have questions for us, please send them to us via our website, spacenutspodcast.com, spacenuts.io, and send it to us simply by clicking on the relative button. You can click on the AMA tab where you can send us audio or text questions, or on the right-hand side, there's this weird green button that says send us your questions. When you hover over it, it turns purple. Yeah, I don't know. But you can send us your question there. As long as you've got a device with a microphone, all good. And don't forget to tell us who you are and where you're from, and we'll do our best to give you an answer. Fred, that's the end of another episode. Thank you, sir.
Pleasure. Good questions there and great stuff. Keep them coming in, folks. It's great.
Indeed. Yeah. All right, Fred, catch you next week.
Thank you.
Professor Fred Watson, astronomer at large, and thanks to Hugh in the studio who funneled through a couple of late questions that we managed to, we put one on the back burner and we tackled the other. And from me, Andrew Dunkley, thanks for joining us. Catch you on the very next episode of Space Nuts. Bye-bye.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com.
This has been another quality podcast production from Bytes.com.